Welcome everybody to, I guess we're calling these solving stuff with Sosa. So in this video, we are going to be solving a couple of circuits that have to do with resistors in series and parallel. So here we go. And so we are going to be analyzing two circuits. Both of these circuits have a series of resistors connected in series and parallel, and these are also connected to a power supply. For each of the two circuits, we want to find the equivalent resistance. We want to find the currents, voltages, and power across each of them, and also find the total current and power supplied by the battery. Okay, so let's start off with circuit number one. Okay, so we are going to start off with circuit number one. Circuit number one has four resistors. R1, that's 7 ohms, R2, that's 10 ohms, R3, that's 6 ohms, R4, that's 4 ohms, and this network of resistors is connected to a 24-volt power supply. So we are going to analyze this circuit to find the currents, voltages, and power across all of these elements. Now I'm going to turn off my camera because I've noticed that the box where the camera is going to interfere with some of the things I want to show on the slide. So you will not be seeing me, but you will be listening to me, hopefully. So just imagine I'm there, okay? And so we've got the circuit here, and we're going to start analyzing the circuit and trying to find, first off, the equivalent resistance. So the first thing that we notice here is that we've got an array of two resistors, which is R3 and R4. These two resistors are going to be connected in series. And so if they're connected in series, we are going to have an equivalent resistor right here whose value is the sum of those two resistances. So it's going to be 6 ohms plus 4 ohms, which is going to be 10 ohms. Now, we notice that we have another two resistors that are now going to be connected in parallel. And so that parallel array is going to generate a new resistance whose value is going to be the result of the parallel network. And the parallel resistance is going to be the reciprocal of the sum of the reciprocals, right? And so something that you notice here is that the two resistances in the parallel array, are of the same value, 10 ohms. And if we have a parallel array where both resistances have the same value, then the equivalent resistance of that array is going to be half the resistance, which in this case is 5 ohms. And now we have another array here, which is the last one, which is two resistances that are connected in series. So these two resistances are going to create a series array that in the end is going to give us the equivalent resistance of the whole circuit, which is going to be the 7 ohms that we have on R1 and the equivalent resistor that's connected in series, which we found was 5 ohms, and that's going to give us 12 ohms. This way we have found the equivalent resistance. Now we can start finding the currents and the voltages. If we've got the equivalent resistance of the array, then the current of the whole circuit, or the current provided by the battery, is going to be the 24 volts divided by the 12 ohms of the equivalent resistance. And this is given by Ohm's law. So the current here in the equivalent circuit is going to be 2 amps, which is 24 divided by 12. Now, once we have that, we can start going backwards in the circuit so we can find the rest of the voltages and currents. So now we're going to go from here to here, okay? And so if we've got the current of the whole circuit and we've got two resistances that are connected in series, this is going to be the same current that's going to be flowing through this circuit. And so that means that R1 and R and this combination, which is 3 plus 4 parallel with 2, is also going to have the same current of 2 amps. So I1 is going to be equal to the current going through the array, here the 3 plus 4 parallel 2, and that's going to be 2 amps also. If we know that the current going through these two resistors is going to be 2 amps, we can use Ohm's law to find the voltage in this resistor, which is the array we did previously. And that's going to be 2 amps multiplied by 5 ohms. That's going to be 10 volts. And we can also calculate the voltage in V1, which is going to be 2 amps multiplied by the 7 ohms, which is going to be 14 volts. And now from here, we now go back to the previous circuit. And what we find there is that this resistor, which is the 3 plus 4 parallel 2, is the product of a parallel array, if you remember. And in a parallel array, the voltage is going to be the same. So that means that the voltage in this resistor, R3 plus 4 parallel 2, is going to be the same voltage in V2 and in R3 plus 4. And so with that voltage and the resistors, we can find the currents. The current going through the 3 plus 4 is going to be 10 volts divided by 10 ohms, 1 amp. And the current that's going through I2, or R2, I'm sorry, is going to be 10 volts divided by 10 amps, which is 1 amp. So the current is actually the same. And that makes sense because the resistance is the same. Now with these two currents, now we jump back to the original circuit here. And jumping back to the original circuit, we know that R3 plus 4 is coming from a series connection. So that means that the current in I3 plus 4 is going to be the same current going through R3 and R4, which is going to be 1 amp. And from there, using Ohm's law, we find that the voltage in 3 is going to be 1 amp multiplied by 6 ohms. That's 6 volts. And the voltage in resistor 4 is going to be 1 amp multiplied by 4 ohms, which is 4 volts. I'm just going to remove these so we can see those clearly. And that way we can find the all of the values. And again, the logic is once we find the equivalent resistance, we start going backwards, kind of unraveling the circuit and using Ohm's law to find the values that we're looking for. Okay. Now the last thing that we need to find is the power in each of these elements. Now, to find the power in each of the elements of the circuit, we know that power equals voltage times current. So just let's do a kind of a summary of the values we've found up to this point. We found the equivalent resistance, which is 12 ohms. We found the total current, which is 2 amps, and we found each of the voltages and currents in each of the elements. So we've got those here. Now, first we can find the total power, and the total power is going to be the 24-volt power supply multiplied by the total current, which is 2 amps. That's going to give us 48 watts. And now we can find the power in each of the elements. So power in resistor 1 is going to be, well, voltage 1 multiplied by current 1. That's 28 watts. The same applies to the rest. Voltage 2 multiplied by current 2, 10 volts times 1 amp is 10 watts. The power for the third resistor is going to be voltage 3 multiplied by current 3, 6 volts times 1 amp is 6 watts. And the power for element 4 is going to be 4 volts, or V4 multiplied by 1 amp, which is I4, that's 4 watts. And guess what? If we add all of these elements, what do we get? We get 48. And that makes sense. Why does it make sense? Because the total power that's supplied by the power supply has to be distributed in all of the elements. So the total power of the power supply has to be distributed into the four elements that we have here. And so the sum of all of the powers from each of the elements has to be equal to the power provided by the power supply. This is the solution then to circuit number 1. I hope you had fun. Now let's go over to circuit number 2, and I'm going to be doing the same thing. I've got my camera off, so imagine I'm there. And so for circuit number 2, what we've got here is that first off, we notice here that we've got two resistors that are R2 and R3 that form a parallel array. And so this parallel array is going to give us another resistance here that is going to be the reciprocal of the sum of the reciprocals. So it's 1 divided by 6 plus 1 divided by 13. The reciprocal of that is going to give us 4.10. By the way, I'm rounding out the decimals here for this example, but if you want, you can use all of the decimals. And now the next thing we notice is that this parallel array combined with R1 is going to give us a series combination. And so that series combination that we've got here is going to give us another resistance, which is actually going to be the equivalent resistance of the circuit, which is going to be 1 ohm, which is R1, plus the 4.10 that we just calculated. That's 5.10. Now, with those values, we can start again calculating the currents and the voltages. So we've got the equivalent circuit, we've got the voltage, which is 12 volts, and the equivalent resistance, which is 5.10. From there, we can find the total current that's going through the circuit, and that's going to be IT, which is 2.35 amps. And then we're going to start doing the same thing we did for the other circuit. We're going to start going back. So if we go back to the original circuit, this equivalent resistance comes because we had two resistors in series. So that means that we're going to have the same current here also. So that means that current 1 and current for the parallel array 2, 3 is going to be the same one. With this current and using Ohm's law, we can find the voltages in V1, and we can also find the voltage in the parallel array, just multiplying the resistances times the current. So the current is 2.35, and multiplied by 1 ohm, we've got the 2.35, and then the parallel array is 2.35 times 4.10, and we've got the two voltages. Now, again, with this result that we have here, we go back to the original circuit, and we know that R2 parallel 3 is coming from a parallel array, and so that means that the voltage in 2 parallel 3, the 9.65, is going to be the same voltage in both R2 and R3, and from that we can find the currents that are going through R2, which is going to be the voltage divided by the resistor, 9.6 divided by 6 ohms. Actually, I rounded out here, so this is 9.65. Okay, and we can also find the one in R3, so this is also going to be 9.65. Okay, that's rounding. That's doing a roundup of the decimals. And so now we've got the currents going through each of the elements. Now the other thing we need to find is the power. And so now we've got the voltages and currents for all of the elements in the circuit. So now what we're going to do is that we're going to find the power. So let's do a recap of the values we found. We found the equivalent resistance. We found the total current. We found the current and voltages in each of the elements R1, R2, and R3, and with those we can find the power in each of the elements. So we'll start off with the total power. It's going to be the 12 volts multiplied by the total current. 12 volts times 2.35 amps is going to be 28.2 watts. And now we can find the power in each of the elements. So the power in resistor 1 is 2.35 times 2.35, which is the voltage 1 and current 1. The power to resistor 2 is going to be voltage 2, which is 9.65, multiplied by current 2, which is 1.6 amps. Power to resistor 3, it's going to be 9.65 volts. That's a parallel array. That's why the voltage is the same, or V3, multiplied by current 3, which is 0.75 amps. And that gives us three powers, which is 5.53, 15.44, and 7.23 for R1, R2, and R3 respectively. And guess what? If we add all of these together, we are going to get 28.2 watts, which is the power provided by the power supply. So energy needs to be conserved. So we're providing 28.2 watts, and we are distributing that into three resistors that give us three power values each one. And if we add those, we get the total power supply. So now with this, we've solved circuit 2 and found all of the elements that we were looking for. And hello, so now I'm back and now you can see me. Hello. So I hope you understood the procedures we followed, and not only understood them and learned something, I hope you had fun, or at least as much fun as I did recording this. So let's make this viral. Solving stuff with Sosa. Bye-bye.